Hello, in this video we will talk about cryptographic hashing. Imagine you were invited over by your friends to watch a murder mystery movie, and halfway through this movie you realize that you have solved the puzzle. You know who the killer is. Now you are faced with a dilemma. Do you tell your friends who the killer is, showing everyone that you have solved the mystery, or do you stay quiet and not ruin the movie? However, you will not be able to prove that you have solved the mystery. But then you come up with a bright idea. You open your computer and you type in a few commands. You write the string containing the solution. In this case, you write "it was the butler," and you hash the contents of that string. Then you use the result, the hash code, and you give it to your friends. Your friends look at you weirdly, but they stay quiet and they keep on enjoying the movie. The movie is not so interesting to you anymore because you have solved the puzzle, so instead you go on the internet and you buy yourself a good book about cryptography that will tell you more about hash functions and a lot of other topics from cryptography. The movie finally finishes, the killer is revealed, and everyone looks back at you wanting to know what you want to do with this hash code. So you open your computer again, type in the same command that you typed before, and then they can match the resulting hash code with the code that you have given them. And because the hash code matches, they know that you have arrived to solving the mystery before the end of the movie. In this way you have impressed your friends, but you have also ensured that they will never invite you again to watch a movie. Hash functions have this property that when you give to the hash function an input, and this can be anything like a file or an image or a text as we saw before, this hash function gives us back a fixed length code for that file. Think about this hash code as being kind of a summary of the object that you have used for your input. If you give that same object back into the hash function, it will always return the same output. And the length of this hash code for that hash function will always be the same. When we talk about cryptographic hash functions, we usually refer to hash functions that satisfy three main properties. The first property is what is known as the pre-image resistance. This means that when we pass our object into the hash function, giving us the hash code, there is no way from that hash code that we can get back to the original object. In our example of the murder mystery movie, we couldn't from the hash code get back to the string that we used. This ensured that our friends wouldn't be able to find out who the killer was from our hash code, ensuring that we don't ruin the movie for anyone. The second property is called the second pre-image resistance. This means that when you know the input that was used to produce a particular hash code, you cannot find another input that when you pass it through the same hash function, it gives you the same exact code. This is useful for certain applications. For example, you might have seen this when you download a file from the internet. Certain sites give you a signature for that file. This is just a hash code for that file. After you download it, you can check that the hash code for the downloaded file matches the one that is on the website. This ensures that when the file is located on different mirrors, the owner of that mirror, the hosting company of that server, will not change the file with something else. And the second property ensures that there is no easy way to do that. There is no easy way to find another file that hashes to the same code as the original one. The third and final property is the collision resistance property. This means that it's very unlikely that two objects, when using the same hash function, hash to the same code. This is different than the second property when you know one of the inputs. There are several applications where you can use hashing. Typically in these applications, hashing is not used by itself. It's used with other cryptographic techniques. We have already seen one application, that of making a future commitment. When we had the example of the murdery mystery movie, we can also apply this technique to other scenarios such as payments and transactions. The other application of using hash functions is to do with integrity. We saw the example before of the file being downloaded from a mirror from a different site than where it's being advertised, and to ensure that the file is the same file that's being advertised on the website, we can use a hash code to match the hash code of the file that we have downloaded. Another application of using hash functions is when we need to come to hide values. And one good example of this is for the use of hiding passwords. Typically, we don't store clear text passwords in databases because if someone gains access to that database, he will have access to all the passwords. So what we do is apply a technique called salting, and then we hash the result. And instead of storing the clear text password, we store that hash. This ensures that if someone gains access to the place where we store our hash codes, he will not be able to reverse that hash code to obtain the password. There are many different cryptographic hashing algorithms. These are some of the most common ones. The MD5 and the SHA-1 are not considered to be secure anymore because they've been proven that they're not collision resistant. The SHA-2 and the SHA-3 are safer to use, and there are various variants of these algorithms in that they produce different output lengths. In our examples, we were using the SHA-2 256-bit hash function. Let's have a quick look at how the algorithm of the SHA-2 works. The SHA-2 algorithm works by breaking down our input into fixed size blocks. In this example over here, we're using 8 bytes because we didn't have a lot of space on the image. However, if, for example, we're using the SHA-256, this block size would be equal to 32 bytes. After dividing our input in these fixed block size and perhaps padding some of this input, we feed each block as an input, together with a fixed value. These two inputs feed into our compression function, and the compression function combines these two inputs into one single output of the same length. This output is then passed back as the second argument input to this compression function, and as a first argument to our compression function, we use the next block of our input. And again, the process repeats. These two inputs are combined into one compressed output, and this output is fed back as an input to the next iteration. And we set the other argument for our compression function to be the next block in our input. And this process repeats until we have processed our entire input, at which point we use the final result as our output hash code. If you enjoy these kind of videos, please consider subscribing and liking this video, and also check the links in the description to support this channel.